Hello there. Today in our calculus topics, we're going to talk about derivatives. This is the first day, so you're just trying to understand what a derivative is and what it looks like. So we're not going to really calculate a derivative. We'll learn that later, maybe on a couple easy ones. But we're just going to understand what it is. So our title here, we're doing our intro to calculus. We are on derivatives. Day one. Okay, all right. So today we're just trying to get a sense of what a derivative function is, like what it looks like. So first of all, for the derivative, let's talk about the notation. All right, so when you're given a function like f of x, or you might be given y or something like that, that's your function. So if you're going to do the derivative, it looks like this. F prime of x, that little apostrophe, I guess you call it, is called a prime, f prime of x. Or you might see it like this, y prime. Or you might see it like this, dy dx. That means the change in y with respect to x, or the derivative of y with respect to x. So this is for the derivative. Now, this is for the first derivative. There's also something called the second derivative and the third derivative and things like that, but of course you have to get to calculus to learn that. All right, so let's talk about what a derivative means in a picture. In a picture, derivative is like all these things kind of simultaneously. It's the change in y over the change in x. So it's like the instantaneous change. And so you notice change in y over change in x. Hopefully that reminds you of the slope. So it's like the slope of a function or a curve at any particular moment. All right, so back in Algebra 2 or earlier this year when you had to tell me things like, when something's increasing or decreasing, right? So let's say I gave you a polynomial and you would be moving along here and you'd say, oh, this is increasing, then it's decreasing, then it's increasing. What you were really doing is you were analyzing the derivative. When something's increasing, it has a positive slope to it. When it gets to the very top, it has a zero slope, and then it starts going down, negative slope, and then positive slope. So at this high and this low point, the slopes are zero, and I'll show you why that is in a minute as well. All right. So you can also think of the derivative as the velocity of an object. Traveling along a path. And the path that you're traveling along is the function itself. So like if you're traveling along like this path, like your velocity is pretty steep right there, pretty high, and then it kind of falls off and flattens out, and then your velocity, you're decreasing really fast, all right, and then you kind of slow down and come to zero, and then you start to go fast again, all right? So it's the velocity of your of an object. And last thing is what we're going to focus on in a minute. It is the slope of a tangent line. The slope of a tangent line to a function at a point. And you'll see in some pictures what I'm about to show you. All right, so I'm going to go to Desmos. I made some pictures here. Now, let's say you're given this function. So this function right here, this is a line. It's y equals 2x plus 1. That's the equation of this red line right here. So, the slope of a line is always the same. So if I move this dot here, the slope never changes. It's always 2. And so when you graph the slope of this line, it would be this green line right here. It would just be always 2. All right, we'll come up with some more examples in a second on that. All right, so now let me go to one that's a little bit more complicated. Okay, and so here I have just like your basic parabola, right? All right, so on your basic parabola, on the right side, you see if I move this along, there's the slope, those numbers changing over there. So like right here, I'm at the x value of 1.8, and my slope of my tangent line is 3.64. So you see if I move it up, parabolas get steeper and steeper and steeper. So you see that green number, it's rising. If I come back down, the tangent line gets flatter and flatter and flatter and flatter, lower and lower and lower, until right here the tangent line is 0. If I can make it stop there. Right there. Oh, I almost had it. Right there. So the tangent line is 0. The slope is 0 because it's the flat line. And then if I move to the left, you see it turns into a negative because it's decreasing. So here it's more negative and more negative and more negative because it was a steeper slope, but a negative slope. All right. So let's look at another one kind of similar to that. All right, give me a second for this little yellow thing to go away. All right, so here I have another parabola, and so it really, does the same thing as the last one. You see the green numbers going up as I move to the right, and then it goes towards 0 right there, and then it's decreasing on this side, so it has a negative slope. So I want you to notice here is that I can tell where the maximum or minimum of the parabola was because that's where the slope is equal to 0. So right there, the slope is equal to 0 at -3. So I'm at -3, the slope is 0, so it must be a max or min. Before that, the slope is negative. So my graph is decreasing, then it comes to 0, then it starts increasing. Well, that must mean I've gone down, and then I've turned to go up, so it must mean I have a minimum spot. All right, so we'll do one more of those, and then we have an even harder one. All right, so again, let me wait a second for this to go away. So I can close that. All right, so this parabola right here, so notice it's upside down. So this time on the left, my graph is increasing. And notice, the slope is less steep and less steep, less steep. It's flattening off until I get to 0 right there. Okay, oops. And then once I'm over the hump, it starts to decrease and it gets more and more negative. Okay, but what I can tell from this, I can tell that right here at 2, the slope was 0. So I know that that must be a max or a min. And then before it, the slope was positive, so I was rising. I got to my maximum, and then the slope was negative, so it had to come back down. All right, and the last one right here. So the last one, you're not going to have anything like this on your homework, but I just wanted to show you because it's just a more interesting graph. Okay, all right, so this one's a cubic function. So let me move it back over here to the left. So you see this thing is increasing, and so I'm increasing. My slope is that purple number, okay? And it's getting less and less because this is flattening out to right here. My slope is 0, and then it turns negative to a negative slope. It's decreasing, and it's turning to 0 right there again, and then it's increasing, okay? So here I have a max and a min. So notice what was happening with my slope. It was positive, so I knew I was increasing until I got to that place. The slope is 0, and then it turned negative. So when something's rising, then falling, you must have a maximum. And then when something's falling and then rising, so you notice your derivative is negative, then it turns positive. Oh, well, you must have had a minimum. Okay, so there's going to be some key concepts that we're going to need on our examples that we're going to do. Okay, all right, so let's work on a few examples here. So my first example here is going to be, I'm going to give you this problem. F of x equals -3x plus 5. Now this is my main function. So if I asked you what is f prime of x, I am just asking you for the slope. I'm asking you for the slope of that function, the slope of the tangent line. Well, think of this graph. This is just your basic y equals -3x plus 5. So it starts at 5, goes down 3 over 1. So this is just a line, all right? And the slope of a line is always literally this number right here. So what is f prime of x? it would always be -3. It wouldn't change. All right, so lines, they have a constant slope, so that's an easy one. All right, it gets a little bit harder when you start to do things on parabolas and things like that. So let's see, this one, example 2, let's say I give you this function. I have x minus 3 squared plus 1. And I ask you, what does the derivative look like? So f prime of x, the picture of it. Like, what will it look like? All right, so let's take a look. So this graph right here, x minus 3 plus 1, it's a parabola that's been moved to the right 3 and up 1. And it's just your basic old parabola sitting there. All right, so think about the left side. This piece right here, this is decreasing. The tangent line right here would be 0, slope of the tangent line, and then it would turn increasing. So this spot right here is important. The slope of the tangent line right there is 0. So I know that on the graph of my derivative at 3, what's going to happen is I am going to cross 0. So the derivative is 0 at your minimum spot right here. So I know that, and then before this minimum spot, the slope was negative because it's decreasing, and then it was positive, increasing. So what I know about my graph, I don't really know a whole lot about the slope, but I do know that it was negative and then positive before and after the number 3, because that's where everything changed. Okay? All right. And notice also that when you have a problem, notice that like your powers, the original function had an x to the first power. Look at your derivative. It doesn't have an x at all. The original function has an x squared. Look at your derivative. It just has, it's an equation of a line, mx plus b. So it has x to the first power right there. That's a little something to notice for later. All right, so the next one, I'm going to turn it around a little bit. And I say to you, I'm going to give you, given f prime of x looks like this. So the derivative of a function, some function, looks like this. It goes right through here, and this is the line y equals 2. So 1, 2, 3, 4, so this is at 2. All right? So think about it. If your slope is always 2, that must mean that you had a line whose slope was 2. All right? So the question here would be, what does f of x look like? What are some possibilities for f of x to look like? So all we really know about f of x is that it's going to be a line with a slope of 2. All right, so I don't really know what it's going to look like, but like it could be anywhere, but the slope has to be about 2. And so if I think about 2, I'm going up 2 over 1, up 2 over 1, so about slanted like that. So it could be there, it could be over here, it could be here, it could be anywhere, but as long as the slope of the line is 2. All right. All right. And let's do the next one. All right. So actually, let me go to the next page for this one. All right. So let's say I had, I was giving you this. I'm giving you that f prime of x looks like this. It's going through the spot -2, and what it's doing is it's going like this. It's a line through -2. All right, now it's really important that you recognize this is the derivative. So what you can tell here is that at -2, the derivative is 0. So that must mean you have some kind of maximum or minimum. So let's look what happened before. So before -2 right here, the slope is positive. These are all positive y values. My f prime of x is positive right here. So it's important to recognize that that's like a different way of looking at a graph. My f prime of x is positive, and down here f prime of x is negative. All right, so this whole part of the graph right here, my derivative is positive, and then it becomes negative. And in between that, it's 0. So imagine you have a graph where you have a positive slope, you come to a 0, and then you have a negative slope. So that's what your graph is going to look like, your original picture. And you know that that all happens at -2. So if I try to graph the original, what does that look like at -2? All I would know is that I had to be increasing before -2, and then after -2 I had to be decreasing. And my slope at -2, my tangent line, has to be 0 right there. Okay? All right, so that graph could look like that, or maybe it could look like this. It could be down here. There's no reason to say it can't be down there. All right, so some kind of parabola most likely. All right, so let's do a couple problems with a table. All right, so let's say I was given this table. I was given x and f prime of x. So this is my derivative, my slope. So my x's are -2, -1, 0, 1, and 2. And my slope is 4, 4, 4, 4, 4. All right, so let me ask you this. What is the equation of f prime of x? All right, so all I'm really asking you is, what is the equation for this table I've given you? Well, think about this table. If you were to graph this table, at -2, the answer is 4. At -1, it's 4. At 0, it's 4. At 1, it's 4. At 2, it's 4. Look at that. You just have a line. Y equals 4. So the equation of f of x is, f prime of x equals 4, the derivative, okay? So what that means is that your original problem always has a slope of 4. So what could be f of x, the original problem? So all I know about f of x is that it always has a slope of 4. Well, what kind of things always have slopes of 4? Well, those would be lines. So my original function could be something like this, maybe 4x plus 2, or maybe my original function could be 4x minus 8. I mean, all I know about it is it has to be something that the slope is always 4, and that would be a line where you have a slope sitting here of 4 somehow. Okay? All right, so another problem like that, but a little bit different. So let's say we're given x and f prime of x again. So with my derivative here, and I get -2, -1, 0, 1, 2, 3, 4. And let's see, I get -8, -6, -4, -2, 0, 2, 4. All right, so let's take a look again. Same questions. What is the equation of the slope function of f prime of x right here? So let's try to do a little graph. At -2, I got -8, at -1, -6, 0, -4, 1, -2, 2 is 0. Now my picture is not so great right here. You know what? Let me go get a graph. I think I have a little graph in my pictures here. Yep, I do. That's good enough. All right. So that would be much better. All right, so let's do this then. All right, so here we go. So -2 is -8. All right, -1 is -6. 0 is -4. 1 is -2. 2 is 0. That's important. 3 is 2. 4 is 4. So look at that. I just have the equation of a line. Okay, so this line looks like it has a slope of 2. So I get 2x, and it's touching at -4. So remember, this is the derivative function, right? So the equation of f prime of x equals 2x minus 4. So remember, that's the equation of the information in this graph right here in this table, right? So for part B, what would my original function look like? Original f of x. What is that going to look like? Well, my original, let's see. So what happened here was at 2, my derivative was 0. Before 2, my derivative, because remember, this is a graph of the derivative, so my derivative is negative, and here my derivative is positive. So what's happening to me is I'm going down, and then I'm coming up. And then right here is where my derivative was 0, and that corresponds to right there. So my original function has to look like this then. At 2, I have like a max or a min. If I am a negative, then I'm positive. That means I'm going down, and then I get to 2, and I'm flat, and then I go back up. So this could be my original graph. Or, you know what? My original graph might also look like this. It might be down here, but it has to be at 2. 2 is the place where my turn is going to be. Okay? All right. So 2 last little examples here. Not difficult. This is just to prepare you for something later on. Later, you're going to be learning more about this expression here. This is called the limit definition of a derivative. Oops, derivative. All right, it goes like this. The limit as h goes to 0 of f of x plus h minus f of x over h. So that's going to be a limit that we're going to evaluate later to find the derivative. That's like called doing a limit by first principles, or the definition of a derivative, way to do the limit definition of a derivative. And so for right now, we're just going to do an example that kind of helps us with this. Okay, so let's given this function, f of x equals 3x minus 1. So let's find these things. Part A, let's find f of x plus h. All right, so f of x plus h, I'm just going to plug in x plus h for x. So f of x plus h would be 3, and then I'd put x plus h there. So I'm just putting x plus h right here, okay, and then minus 1. So let's figure that out. That would be 3x plus 3h minus 1. That's it. Letter B, let's find f of x plus h minus f of x. Okay, so we basically have the answer we had before, 3x plus 3h minus 1 minus f of x. Well, f of x was 3x minus 1. So if I look at that, these 3x's are going to go away. Then I'm going to have 3h minus 1, and then 2 minuses make a plus 1. So those go away, so that would just be 3h. So then part C, I want to know what is f of x plus h minus f of x all over h. So if I take that answer that I have, which is basically the top part, so that's 3h over h, and so that makes 3. Now, the limit part of this won't really be doing much else, because look how we're getting a constant right here. So you knew that when I told you this line function right here, you know the derivative is 3, because you know the slope of a line is always sitting right there. So actually, it should make sense that its answer came out to 3. All right, last example. Let's do this one. F of x equals 4 minus x squared. So we're going to go through the same process. Let's find f of x plus h. So that would be 4 minus x plus h squared. So it would be 4 minus, if I square that, remember I get x squared plus 2xh plus h squared. And we get 4 minus x squared minus 2xh, whoopsie, minus h squared. All right, so there's not much else I can do there. So letter B, I get f of x plus h minus f of x. So I'm going to take this answer I had before, 4 minus x squared minus 2xh minus h squared. I'm going to take away 4 minus x squared, which is f of x. So I notice right away that these 4's are going to go. And I have negative x squared here, and this is going to turn into a positive x squared right there. So that's going to be gone. So what I get is negative 2xh minus h squared. All right, and then letter C, going f of x plus h minus f of x over h. So I'm going to take this answer I had, negative 2xh minus h squared over h. I'm going to reduce it because they all have h's, so I get negative 2x minus h. Now I want you to imagine, so this is the answer, but I want you to imagine for our future purposes, if we were doing the limit as h goes to 0 of this expression, negative 2x minus h. Well, what would happen is this h right here is going to 0, and the negative 2x is just going to sit there, so the answer to this is negative 2x. Now your answer in math space is going to be this right here, because you don't know this other part yet. But later, I'm going to ask you to come up with this answer right here, and that, my friends, is the derivative of this function. So f of x is 4 minus x squared. The derivative of f of x, f prime of x, is negative 2x, which is some fact that you're going to practice more later. And that is it for